All right, hello, we're team A16. We are doing the application of intelligent transportation systems to maximize the level of service at Girard and Broad Street intersection. My name is Gianni. We have a team of 5, 2 civil engineering students, 2 electrical, and 1 mechanical. So we have a pretty good, diverse engineering background.
The Girard and Broad Street intersection is one of the most dangerous intersections in Philadelphia because there are 2 bus stops, 2 subway station stops. That's the reason why there are so many people appear in this intersection. And unluckily, the design of the traffic line is unscientific. So people have to wait at least more than 60 seconds to pass the street. They often choose jaywalking. And this behavior is very dangerous. So in our projects, we'll find a way to solve this problem.
Functional requirements of this project is to increase the safety of pedestrians while also improving the level of service intersection, maintaining a conservative budget. Our design constraint is to comply with multiple manuals, including the Manual of Uniform Traffic Control Devices, Highway Capacity Manual, and Works Engineers.
So our design approach was to retime the signal lights in times of high pedestrian flow volumes. And we know that lots of pedestrians arrive simultaneously at the sidewalk when a subway train arrives, and all pedestrians must pass through the exit doors, the designated exit doors below ground. So we engineered a sensor that counts people as they exit the door. And when the sensors count enough people exiting, they will automatically trigger a shortened signal sequence that allows the pedestrians to cross at typical walking speeds. Once the pedestrian sequence runs twice all the way through, the lights will return to the standard timing plan that's already optimized for motor vehicles.
So as we can see, the picture on the left is a picture of the turnstiles doors on the subway station. And on the right, we have a picture of the selected sensor we chose. We did choose a laser sensor, which is an infrared sensor that detects the movement of people when the light signals gets interrupted. And the 2 parts of the sensor will be mounted on all rotating doors in each side of the rotating doors. And when people pass through these rotating doors, the sensor will count the rotations, and we will get that data, and we will get the data we need.
So trying to tackle our functional requirement, we decided to have a really good amount of data. So we decided what is the peak hour, and after that, we took a video footage for the intersection for about a 12-hour period during the day, and tackle every thing in it. And we reached over 43,000 of data points for this study. And we have in figure 4 an example for the footage that we took. And Gianni will talk about the result of this data.
Right, so in order for us to do a level of service calculation, we need lots of data, and 43,000 data points was perfect. That provided us enough information for us to determine the level of service based on the existing signal timing plan. And as you can see on this chart down here on the left, the existing timing plan yields a level of service score of a C, which isn't terrible. But based on those same conditions, if we were to retime the signal lights, the cycle time was found to that the level of service score would be optimized when the cycle time was actually at a 57-second cycle time. And at this time, the level of service score was increased by a full letter score, and the average vehicle delay time was decreased by nearly 4 seconds, which is very substantial.
Since our intersection is one of the most dangerous intersections for the pedestrian, we tried to create our own pedestrian sequence through our data collecting. And we did that through minimizing the green sign for the pedestrian to cross the street.
In summary, we were able to meet our functional requirements by improving the level of service from C, increasing the safety for pedestrians and maintaining a conservative budget. We're also able to comply with all our design constraints and complied with manual and all the standards of Philadelphia. We believe this design can be used throughout Philadelphia and throughout cities and even on a global scale.
Thank you so much. We look forward to seeing you at our presentation on Friday.